Today's show is brought to you by CBT Nuggets. You know how much we value ongoing education on the Cloudcast, and CBT Nuggets is exactly what Aaron and I wish we had when we were trying to get our certification early in our careers. CBT Nuggets is all about bringing a personalized touch to learning about cloud computing, virtualization, networking, DevOps, and much, much more. Whether it's their hands-on labs with personalized coaching or the online chat functions that come up with every instructor-led course, CBT Nuggets' team of experts is always there to help you get the most from your training and your path to certification. You can check it all out at cbtnuggets.com/cloudcast and sign up for a free trial. You get access to the full catalog of great training, including virtual labs, quizzes, and other premium features completely free for the first 7 days. That's cbtnuggets.com/cloudcast.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. It is mid-May, and Cloud News of the Week, we're going to roll right into it. We have a number of articles this week. Number one, an ascension to CEO at VMware, an acquisition in the news, and some new features coming out as well for some big names out there in the industry. With that, we'll jump into the first article. VMware this week, in a move that probably didn't surprise a lot of folks, named a new CEO. Of course, Pat Gelsinger, very well received and well liked CEO, moved on to Intel. It was just a matter of time before they named a successor. I think everyone in the industry kind of realized they were probably going to do this internally, and it was down to one of two candidates within the company, Raghu, who ultimately became the CEO, or Sanjay Poonen, who actually announced his departure from the company as well. If you've followed VMware for any length of time or been in the virtualization circles, Raghu has been around, very well known, and very well liked as well. And we certainly wish him the best as he takes on the new reins at VMware. For our second article is actually an acquisition. And this was Twilio. Twilio bought ZipWhip and bought them for a very nice price, $850 million. Now, I wasn't familiar with them, so I had to go do a little bit of digging on them, but it was really fascinating and really good technology and very complementary to what Twilio already does as their core business. ZipWhip was all about texting and texting communications for businesses. And that may sound like, well, that's something we already do today, but this was back in 2013 when they were really founded. And they were founded on the premise of, hey, businesses need to start texting as communications. That's what a lot of us as consumers like. And let's be honest, who answers their cell phone anymore, especially from an unknown number? So very good acquisition for them, and it'll be really interesting to see how this integration goes over time. And they're hoping to close the deal by the end of the year. Moving on to our third story, we have GitHub. GitHub has officially opened up the ability to do video uploads. Now, this has been in beta for some time as well. And for those of you out there that have been dealing with GitHub, or really anybody who's dealt with bug requests or support tickets before, and how do you do it? Well, how did you recreate this? Well, you click on this and you click on that, and hopefully you can recreate it. Now you can send in a video, right? So it's in pull requests, it's in discussions and issues and comments, just about anywhere. You have the ability to now upload a video, which I think is a really good move forward for them, and really looking forward to this feature as well. And finally, AWS. AWS launched an application migration service. Lift and shift. It's kind of gotten a mixed reputation at times in our industry. Some folks are kind of saying, well, if you lift and shift into the cloud, like, hey, it could be expensive, or you're lifting and shifting, you're just taking all of the legacy and cruft that goes with it and trying to put that into the cloud. And you might be better off refactoring those applications. But there is still a market that's out there, and it's certainly something AWS is going after from an adoption standpoint. Now, what kind of applications could this be? Well, think of any of your typical enterprisey on-prem applications in the past. AWS mentions in there specifically like SAP or Oracle or some of these other kind of ones where doing a lift and shift could be pretty time intensive, pretty error prone, sometimes manual process as well. So I did a little digging on the service. What it actually does under the covers is it's loading an agent on the machines, whether they're physical or virtual, and then replicating everything up into AWS for a certain amount of time into kind of a sandbox area, if you will. And then at some point in time, you're going to be clicking that over. And when you click that over, it, of course, is going to convert everything over, convert that virtual machine or physical machine into an instance, and then, replace the drivers and all of the other things that AWS tools have already done previously as well. And then you're able to be off and running in AWS. It will be interesting to see the use cases that come around this. But of course, AWS is out there always trying to put the customer first and remove friction. And if lift and shift is somewhere you and your business want to go, and this is something you might want to look into as well, and AWS just released that this week. So with that, we're going to move on to our show. This show, we're going to be talking all about serverless with Julian Wood from AWS, and we'll be talking about that right after the break.
Today's show is sponsored by Datadog, a monitoring and analytics platform for cloud scale infrastructure and applications. Datadog provides dashboarding, alerting, application performance monitoring, and log management in one tightly integrated platform, so you can get end-to-end visibility quickly. Be proactive with your monitoring strategy and catch issues before your clients are impacted. Start managing the overall health of your environment with a free Datadog trial. Go to datadog.com/cloudcast for the free trial. That's datadog.com/cloudcast.
Today's show is sponsored by Okta, the leading independent identity solution. Okta provides best-in-class authorization so your customers and workforce can safely access what they need most right when they need it from anywhere. Organizations around the world trust Okta's Identity Cloud to sign in, authorize, and manage users, whether it's employees, contractors, partners, or customers. And with Okta's developer tools, you'll never have to build authentication again. Our customizable code blocks are flexible and future-proof with easy-to-use APIs and SDKs, so you can do less coding and more shipping. Okta is dedicated to building the most reliable, neutral identity platform because it means protecting more than a login. Identity is protecting people, their ideas, their work, their brilliance. It's protecting your future with confidence. Learn more at okta.com. That's OKTA.com.
And we're back. And, folks, one of the things that we used to do, and I'm not really sure how we got away from it, was we used to talk about serverless quite a bit, to a point where we were a little bit obsessed with it. And for good reasons, because every time we would talk about serverless, regardless of kind of the scope of the topic or the focus of the topic, you loved it. The audience, the attendance for shows, listening for shows was always way up. And, we did some things with serverless comp and so forth when it got started. And we, for some reason, have kind of gotten away from serverless, and it kind of dawned on us, we should kind of get back and see what's going on in this space. And it's changed quite a bit. It's evolved quite a bit. So we thought, let's go find some folks who not only live in this space, but are right in the middle of kind of making that change too. So very excited to have Julian Wood join us, who is Senior Developer Advocate at AWS, focused on serverless. Julian, welcome to the show. Great to have you on.
Oh, Brian, thank you so much for having me. It's really an honor and a privilege, and I can, I'm sure we'll get to it, but I can blame some of my work in serverless based on your own work on the Cloudcast, and many podcasts ago talking about serverless and getting excited about it. And I'd be super happy to chat today. And maybe, I'm sure we'll talk about that. Serverless isn't going away because people haven't been talking about it, but it's partly become the new normal. So
yeah, exactly.
I'm loving it, and so glad you asked me to join. Thank you.
Yeah. So you obviously, folks will probably pick up from your accent. You're in London, which is good. We were kibitzing before the show. Neither one of us have gone anywhere, but before we kind of dive into some stuff, just give folks a little bit of your background, kind of what you were doing, say either pre-AWS or pre-serverless, and what kind of has gotten you to being almost entirely focused on serverless these days?
Yeah, certainly. Well, I do live in London, but I'm sure the language purists in the UK will go, he doesn't talk like us at all. So yeah, I'm actually originally from South Africa, but living in London, just to throw the curveball in there. So if there were people tapping their headphones going, hang on, that doesn't sound right, now you know.
There you go.
But yeah, I've spent probably too long, 25 years-ish sort of working as an infrastructure architect and manager and, operator and server racker. And I was involved with, Windows servers and SANs and NASs and virtualization, hyperconverged, a bit of cloud through the years. But yeah, literally very much come from the infrastructure side, which means I've been listening to the Cloudcast I think probably near the beginning, and it's formed a lot of my interest in the industry. So yeah, thank you for not just educating yourselves, as I know you like to say, but us too. Yeah. And then, yeah, I mean, I'd spent so many years in infrastructure. And I really enjoyed what I was doing, but I just, there was so much hard work that infrastructure people are doing. And a lot of that stuff is stuff that's been solved already. Right. And I worked in big global enterprises. And, even within companies, there are so many different ways of doing things and, trying to get standards in place, even on the infrastructure part of view, never mind any platforms or applications or this kind of thing. And I always knew that there were more important and bigger problems to tackle and easier things. And at the same time, I was a sort of independent consultant anyway. And so I'd done a number of public speaking, and I was a VMware V-expert for a number of years. And so, speaking at the great VMugs and, learning from others and sharing and doing a bit of blogging. And then just the sort of idea of serverless started to take hold, and definitely light bulbs went off in my head, and also prompted by you two, speaking on the podcast about serverless in the early days, and just how this was a much better way to do things, and an evolution of cloud as it was. And so yeah, I sort of jumped on the bug of serverless and started talking about it just off my own bat, really. Publicly, and writing blog posts and things like that about it. And then from a sort of the worlds collided and amazing things happened, and I happened to go to reInvent off my own bat once or twice, and blogged all about serverless and other stuff there, and amazingly landed up getting what I think at the moment is the world's perfect job, to get to talk about serverless at AWS, and people actually pay me for it. Well, I hope they do.
It's like they say, find something you like to do and you'll never work a day in your life. So that's very, very cool. It's, not an unusual path, like you said, in terms of you've sort of come up through, all the things that was infrastructure, the toilet was infrastructure, and now you're working in this space that's, kind of to a certain extent making infrastructure not go away, but sort of disappear, if you will, which is the thing that's always sort of fascinated us about the space. I want to start off with kind of a broad topic or a broad question, which is, we're sitting here in 2021. When Lambda first came out from AWS, it wasn't really even called serverless. It kind of got adopted to that. We've joked around, where the name came from before, but it was serverless kind of for a while, and then and serverless and Lambda were kind of ubiquitous to one another, and then we started seeing serverless databases, serverless as a sort of a function as the edge of a CDN. We've seen it as a few different things. Like when somebody comes to you and they say, "Hey, your focus is serverless," how do you tend to think about that? Do you think about it as, "Hey, I'm trying to help you, from an application side, not think about that," or are you talking because the Lambda piece is still super vibrant. There's a ton that goes on, but then the serverless concept is sort of expanded. How do you frame it up for people?
Yeah, exactly. I mean, it isn't the easiest thing to get into, because in IT we are phenomenally bad at naming things. So of course we're going to call something for what it isn't rather than what it is. And yeah, serverless is at the pinnacle of that silliness. But even when NoSQL came out, and then I spoke to DBAs who are scratching their head, going, "Well, if it's not SQL, but what is it? How does that help?" Right. But anyway, we are where it is, and serverless is a name that AWS didn't come up with or anything. It's just sort of landed on it. But maybe just to let's maybe just take a step back. And there's sometimes a danger in our industry that we often focus on the activities and not the outcome. And sometimes that means we focus on maybe a tech tool and not necessarily what the tech tool lets us do. And so for me, a sort of serverless way of thinking or serverless architecture is a kind of choice you make to implement something, and that's because of an outcome you're looking for. We're not building applications for funsies. We're not just deciding to change things because it's a new cool hotness, but there's going to be an outcome. And when you're talking about the sort of upside and the application side, well, serverless is a bit of both of that. And I don't want to do a trite answer and say it's everything, but we want to be able to build apps quicker, and we want to have less ops doing it.
Right.
And so the idea of serverless is, we found a new way of helping people move faster and try to be the fastest way to build or to involve and build maybe what we're calling modern applications. And so when we're talking to developers and operators, there's a problem they're trying to solve. And the developer's job is to deliver value to their customers easier. And, the things they maybe fret about, security and performance and scale, well, how about if those can be our problems to solve? Speaking on behalf of sort of AWS or a cloud service provider, because, their time is valuable. And if there's stuff we can solve, that'd be awesome. And the goal isn't to make, infrastructure cheaper or to drive utilization to Amazon servers or, offload workloads of data centers. It's really to help builders go faster. That's the sort of overall picture.
Yeah.
And it's, the bigger picture is 4 different things. There's sort of no infrastructure to provision or manage. So, you're not thinking about virtual servers or clusters to babysit or anything like that. It should automatically scale with usage. So if you think of elasticity, more request comes in, scales up to cope, and as your load drops, it scales down. So the unit of consumption is maybe something like an individual request rather than something than a server unit. Then number 3 is you pay for value. So you only pay for what you use more, pay more, use less, pay less. And if, ideally, if you use nothing, then you never pay anything for idle. And, that obviously helps with automatic scaling. And then lastly is the sort of, with my infrastructure hat on, I like this, is the built-in availability and fault tolerance. And, an architectural best practice is, build applications across multiple data centers or multiple availability zones when you're talking AWS. And, with serverless, this is something we do for you. You don't think about this. Availability is built into the service. All the serverless services are multi-AZ by default. And so we take on a lot of the infrastructure management for you as AWS. We take on some of the security. You still need to obviously secure applications, but we look after more of the underlying infrastructure securely. And that sort of gives you more time and energy to focus on the building of your apps rather than the management and scaling of the infrastructure stuff.
Yeah.
So, that's the bigger picture of serverless.
Yeah, no, and that helps. And I think what's been interesting as we've watched it evolve was, originally it was kind of this thing where you went, you kind of don't have to think about the operations. You don't have to think about, kind of the underlying infrastructure. That was kind of, what Lambda was originally doing. Yeah, it introduced this sort of new way of, thinking about a function or so forth. But then what was interesting is how it evolved is, we've seen it talked about in terms of like with databases. And so you're like, oh, I don't have to think about like IO so much, or I don't have to think about the thing that was kind of the, always the bottleneck in the back of my head. And then it's evolved, and even in things like with Fargate, where you can run Kubernetes on top of Fargate, but you don't really think about even the core Kubernetes stuff like nodes and like you're just kind of like, you do kind of get back to this idea of like, I just want to have this sort of concept of computing sitting there that has a lot of capacity and a lot of scale, but I don't really want to think about it. And it's been interesting to see how it's sort of evolved. And I'm always curious how, when you work with people that are successful with it, that really sort of adopt it, and you see those folks, whether they're speaking at conferences, like when they get it, like it becomes a mindset. But is that sort of the thing that dawns on them? Is it they just go, hey, it's just 5 less things I have to think about, or is it really, like you said, they're always just completely focused on outcome? I'm curious, does what they think about on the technology side just kind of go away because you don't think about it anymore and they become output focused, or they started being output focused and this just was the place for them to land?
Yeah, I think it's a bit of a mix and match. And I do think, with serverless, it does have a unique challenge, as is there is some new conceptual learning that you do have to go through. It's not as though it's just a lift and shift, or it's not as though, I did, lots of virtualization kind of stuff, and you P2V a server over the weekend, and you don't even need to tell the app owner that had changed over the weekend. It's running on a virtual machine on a Monday morning, all works brilliantly, and you've just done a great migration. You've, given yourself more agility, maybe saved yourself some money, given yourself some more functionality, but you didn't need to tell anybody. Right. But when we're building sort of applications, unfortunately, it doesn't quite work that way. And so, as we start to scale out, applications are often built composed of multiple services, and these are then talking to through each other. And Jeff Bezos, we can blame him for talking about everything being behind an API. Yep. And that was the sort of start of things. But, we'll talk about it when we talk about events, and we're talking about how different parts of your applications are connecting together. You start just by default having a distributed application. But what we want to do with serverless is to say, well, how can I say this? Well, how can we give you access to maybe the entirety of AWS's compute power without you having to become the expert in distributed computing?
Yeah, no, and I think that's always the most interesting thing to me when I hear folks who've kind of adopted different aspects of serverless. I've sort of stopped listening to the technology pieces they talk to, and I really kind of focus in on how are they thinking about really taking an aspect of their business, whether it's a user experience, a way they collect payments, some way they collect, and it's really fascinating to me that there becomes this sort of immediate connection between some aspect of the business and kind of a technical task, but you don't have to think about kind of how you make that task work. And so I think about I enjoy listening to that much more than I do the folks who talk about kind of the mechanisms and the machinery of all the stuff that happens behind the scenes. It is a fascinating sort of clarity of connecting business to technology.
And one of the things to think about it is more sort of, serverless, we bash on the term, but it's obviously often more of a serverful approach to it, a serviceful approach to it. So, and then mess up the word and say serverful, that would even confuse it. But yeah, the idea is to consume services from somewhere else. And that could be an API over the internet, or it could be another part of your business that is maybe providing, a risk calculation API, or a payment API, or a loyalty points API, or some message queue that you just dump things on and things happen. If you start thinking of things as, well, how can I link these multiple services together and use more services that somebody else just manages, maintains, and operates, rather than you having to reinvent the wheel for all these different applications you run.
Right. Let's talk about let's talk about Lambda a little bit. That's sort of the flagship serverless technology for AWS. And, as we look at surveys, the one that more and more people tend to use, it's evolved a lot over time, right? It first got started, it was, limited number of languages. It had, sort of a finite amount of how long a function could run. It was a specific way of packaging that thing. How has it evolved, and maybe even more importantly, like why has it evolved to the broader support of languages? Now supports container images. The runtime runs longer. Startup times are faster. Like, kind of walk us through some of the evolution of where it's gotten to and where it is today.
Yeah, certainly. So, Lambda, if people don't know, is our sort of functions as a service offering. And within the whole big serverless picture, you can sort of think of Lambda or functions as a service as a subset of that, maybe a slice of the pie. And it's a compute engine. It's a sort of cloud code processor that's available. And, we like to think of it as it's where you run your business logic. So this is the stuff that's unique to you. There may be APIs, there may be queues, there may be database engines themselves. That's not core to your business. Your business logic is the, number crunching or the analysis or the something that you can run. And that's, that's where you're going to run into Lambda. And just, a story of the history of Lambda is it, never started as anything as something as serverless. It really started within the S3, which is our big sort of object storage service. And people were having this idea of, well, when I upload an image or when I upload a file to S3, wouldn't it be cool if I could just run some action on that, and I didn't have to run a poller or run a server that used to have to wait for something, or check whether files or objects are going to appear. And so within the S3 org, they were thinking of this kind of thing, and then sort of took a step back, and in sort of big style AWS way, we're like, well, hang on, why do we just have to limit this to S3? Surely we can create this system that for S3, for any other service we've got, if an event of updating a database, or an event of hitting an API, or an event of, uploading that file, can kick off this little piece of compute code. And that sort of was the genesis of Lambda as event-driven computing. This bit of code would run based on an event. And yes, when it started, it was very limited in terms of supported languages and times and all those kind of things. But just to make do some of the highlights of what it can do. Lambda functions can run for 15 minutes. They can have up to 10 gigabytes of RAM, and you basically allocate memory to a Lambda function, and then it proportionally increases CPU, which is up to 6 virtual cores, and some more network throughput and some more storage throughput. So you've got 15-minute runtime and up to 10 gig of RAM, which equals 6 virtual CPUs. And that 10 gig and 6 virtual CPUs has tripled based on reInvent last year. So if you had some sort of process that was taking 43 minutes and you couldn't use Lambda, well, now you've got 3 times the compute. Maybe Lambda could do that as a compute-intensive workload under 15 minutes. So that's just from the timing kind of thing. We've also come out with a billing aspect, which is Lambda is now billed at 1 millisecond intervals. So, I was on it is. Some other smart person on a something else I was talking to says, well, I'm going to have to put in the request for picosecond billing next. And I was like, steady on. Let's do this first.
You guys do know that every time something like that happens, all the rest of us out in the industry goes, who in the world was asking for that, right? Like it was already at the second level, and somebody was like, no, we are so over-provisioned at the second level. We need the millisecond level. We're always just like, wow. I'm sure there's a use case, but like, wow.
Well, the interesting thing is it was before it was sort of per 100 milliseconds. Yeah. And there are a whole bunch of, there are 2 aspects of it. One is getting it under 100 milliseconds. So, there are lots of synchronous requests which hit an API, and, maybe if that's going to take 30, 40, 50 milliseconds just to run, hang on, why are you paying for the extra, 40, 50, 60 milliseconds to round that up to 100? And the other kind of thing is, well, isn't that annoying if your Lambda function takes 102 milliseconds to run? But then you're being charged for 200 milliseconds. Right. So ultimately, it's from the 2 sides is really having that the billing linked to exactly the usage. Yeah. And this for some high throughput applications, people can drop their bills, and we know of customers who drop their bills by 70%. Not by doing anything, but Lambda just got better and faster behind the scenes.
Yeah, no, it is always sort of an awesome accomplishment, and it's I always come back to this thing of, we've been doing cloud computing for, a decade plus, and we finally have the one service that meets the original criteria, which is, you just pay for what you use. Every other one has been, you pay a fee, but you're probably going to have a very large amount of overhead that you didn't actually use. So exactly. It's always fun to see the way that it's improved years over year.
Yeah. So you were talking about some of that.
Off halfway. Yeah.
I cut you off too as well. We got excited. So so some of the other things that have come out. So we got sort of more oomph, cheaper kind of stuff. EFS, which is our basically NFS in the cloud. So you can now connect Lambda functions to an EFS mount, and so that's a way to do shared storage between Lambda functions, which is important for some people. Some of it may be seen as a bit of an anti-pattern, and some of the FaaS purists will say, well, everything should be immutable, nothing should ever be shared between function states. But in the real world, people have got a whole bunch of stuff on NFS, and this is just it's a great way to unlock use cases where people have got big chunks of data they want to read.
Yeah.
Another thing is cold starts. So something people do partly panic about is cold start. So when a Lambda function fires up, it's got some stuff to do before it can even do the work that needs to happen. Maybe it's connecting to a database or other kinds of things. Maybe it's connecting to a VPC. So one of the things we released 2 years ago was far faster connectivity to a Lambda function when it connects to a VPC. So there's no time penalty now for connecting a Lambda function to a VPC. So that unlocks a whole bunch of workloads where you're not waiting around for a network adapter to be created. That gets created sort of outside of the invocation of a function.
Yeah, the one thing I am curious about, so that's super helpful, and again, it really identifies kind of all the places that if you look back at some of the early Lambda capabilities or limitations, again, it's just this sort of consistent chipping away at trying to make it better. I'm curious. Yeah. I'm curious the kind of not so much the thought process, but the use case process of container images now came into Lambda, and it was always this. There was always this sort of philosophical debate of like, do I use containers for stuff or do I do sort of functions as a service? And, I never felt like the packaging was necessarily the center of that conversation, but now container images can be used as the way to bring a function. What sort of drove that? Or was it just people just saying, hey, like, why do I have this divide?
That's sort of what partly was it. Because, we've got customers personally, people love using Lambda functions. It's, they're super easy to create. They're super easy to upload. All that, undifferentiated heavy lifting that you don't want to think about just disappears. But there's now a change that you need to now develop applications in a new way. And, that's a sort of either cognitive dissonance, or you've got a whole bunch of tools that maybe you've started down a container journey and you have tools that already do image scanning, or you have tools that already, create Docker files, or you have a whole bunch of tools that do stuff for your container thing. It's slightly annoying now to maybe have a whole way you manage things for EC2-based stuff and a whole way you manage stuff for containers. And heck, I've got to then have a whole different way of managing stuff for Lambda functions. So what we've done, as you say, is we've allowed you to build Lambda functions as container images. And I'm stressing that images part because containers is also a big word. Containers means a lot of things. It means an isolation technology. And we don't quite need to use, Docker/containers as an isolation technology. We've got something called Firecracker, which is, a separate conversation, which is basically a micro VM. So each Lambda function runs in its own isolated micro VM. But, containers is also a packaging format, which you're talking about, but also, a whole ecosystem of tooling. There's a whole world of container stuff out there. Right. And we wanted to sort of solve two things: have customers be able to use the tooling to package Lambda functions as container images. So it's literally, before you would have files, you zip them up and you send them off to Lambda, and Lambda runs them. Now what you do is you can use a Docker file and you can build your Lambda function using a Docker file. Whole bunch of benefits with that. One is, first of all, there's immutability. Previously, one of the huge power things of Lambda was we would just update the runtime for you. Node.js would be updated. We would just update that for you automatically. That is amazing. That's awesome. But some people are like, hang on, so you're telling me I'm going to invoke my function now and in an hour and it could change? Like that. So with a container image, that's an immutable artifact. You create your container image at runtime, and then you have control over when that image gets updated. You've obviously then taken on some more of the work, but that's something that customers wanted. Yeah. Also, customers wanted to be able to use different flavors of Linux, for example. Sure. So before, Lambda functions only ran on Amazon Linux, and now because you can build Lambda functions from container images, you could use Debian or Ubuntu, Alpine Linux, or anything. And so maybe that helps you build your Lambda functions that you use on-prem, or you use for Fargate or ECS or EK or so anything, and you could use those same container images for Lambda. There's a little shim you've got to put in there to talk to the Lambda service. That's not particularly complicated, but it just makes it easier that you can now use your technology in more places.
Yeah, no, and that makes sense. And again, it's the thing we always tell folks. If you've listened to the show long enough, or you've been around, say, technology long enough, at some point, kind of the purity of the thing that comes out, and you're like, oh, it's pure and it's very opinionated. It's got these exact rules. At some point, somebody will ultimately ask you, and they'll go, "Hey, can you diverge it a little bit? Can you make it less black and white and more gray?" And like that just happens with every technology. So it wasn't surprising to see it happen, but it was sort of fun to watch the purists go, "Whoa, wait a second, hold on, we're doing this thing."
Yeah, exactly. And it's because containers, as I was saying, is a whole bunch of different things.
Right.
That does add some confusion to it. And it's, people are now saying, well, do I use Fargate, or do I use Lambda, or do I use ECS?
Yeah.
And there are more conversations with that. But I mean, ultimately, what are you trying to do? You're trying to run an app. You're trying to do it as efficiently, simply, and cheaply as possible. And, Lambda has some restrictions, so if those restrictions you're bumping up to, cool, use Fargate. It doesn't have to be it doesn't have to be an either-or conversation. Use multiple technologies, but now Lambda may be able to unlock a few use cases for you that you didn't have before. And if that makes you happy, put a smile on my face.
Yeah. When it first started coming out, and when we were first sort of learning about it, I would always explain to people. Think of it sort of like this. You have a piece of code that wants to run, and it's typically going to have a source of something that interacts with it, and then it's going to have an action that comes out of it. And so I'd sort of say, well, you've got a source, you've got some code running, and then you've got this sink that does downstream. And so you could apply a lot of kind of patterns to that. It could be, something ends up in an S3 bucket, a database table change, an event on a message queue or something, and people would go, oh, I get that. And I know of times when that thing happens in our world, and it would be nice if we weren't running these long-running computing resources for stuff that didn't happen all the time. I'm curious, like, as you look at the use cases and the patterns that have expanded, like, do they fit into certain buckets these days, or are they're all over the place because now the capability has expanded so much, the foundational things are just pretty broad?
It is broad because people are using more use cases, but I mean, we do have a few very common use cases. One is the sort of synchronous use case, which is a web or mobile backend, and so you have a client on the front end, a mobile or web app, and we have API gateway, which is our managed API service, and that front end would hit the API gateway, and a Lambda function would on the back end would maybe send something to a database, compose a web page, retrieve something from something, or maybe kick off another whole asynchronous process to do stuff. So that's a sort of the back end of a mobile web app. A lot of file processing. A CSV file gets uploaded to something that then automatically triggers a Lambda function, which maybe does some analysis on that, or creates a thumbnail of a picture, or parses that CSV file and plumps it into some database. A lot of queue processing stuff. So SQS queues, queuing up events and then asynchronously triggering these. This is super useful where the concept of event-driven computing, where instead of having something behind an API where I tell you to do something, you just say, you basically tell the service, this is what I'm giving you. And that backend service asynchronously can go off and do its whole kind of thing, and it's not bound waiting for the caller's response. So that's the whole kind of thing. I mean, there's a lot of real-time processing because Lambda scales out so easily. A huge amount of data can come in, and this is via something. Could be an IoT thing, could be a log stream, could be a stream from tractors or something like that. Right. Lambda can read the stream, analyze it, modify the data en route, maybe do some analytics, and then put it elsewhere. And then, we've got, pub sub services with the SNS, for example. And then a really useful service is something called Event Bridge, which is a sort of event router. And you can receive events from AWS services, as well as SaaS partners, which have partnered with us. And just based on the rules, you can then send those elsewhere. So you could grab something from a SaaS partner. Event Bridge will pick it up and send it either onto Lambda, or maybe send it onto another arbitrary API, or do something. That's another use case. And then a lot of scheduled tasks. So instead of having a server hanging around, something you need to patch and maintain, even if it's small and doesn't cost you much, still needs some care and feeding. And so we see a lot of Lambda being used for something with like CloudWatch schedules. So a Lambda function will run every hour to do a report or something like that.
Yeah, no, that was always the one that kind of threw us at first because we were like, oh, hold on, it feels like it's very application driven, and then we would sort of hear about these folks who go, no, I have dozens of regular just ops tasks that we do all the time that are we would just essentially automate those, but automate them in a way that we're not paying, like you said, for this infrastructure that's just running all the time that we have to maintain. I want to ask you one last question because we're gonna kind of run out of time. For a while we would sort of watch all of the ancillary AWS services become things that could be, sort of sources or sinks for Lambda. So it'd be S3, and then it would be DynamoDB, and then it would be Kinesis, and it would be something. and there was sometimes some talk of like, okay, well, if you're using Lambda, you can only use other AWS services. Has there been any evolution as we see, more services that live in AWS, third-party services and so forth? Like, is there a framework that if, I don't know, I'm a SaaS application, I can sort of tie in natively into Lambda, or are there ways to think about sort of the tools that you've built yourself or third parties that can plug into Lambda frameworks or some of the other frameworks?
Yeah, definitely. Well, there are a number of different ways, I suppose, to chat about that. One is just when I spoke about EventBridge, that's got a whole bunch of SaaS partners. I think there's sort of 30 plus SaaS partners. Okay. And you can think of, Auth0 or Zendesk or trying to think of, I can't think off the top of my head, but these are SaaS partners we partnered through. So a Zendesk ticket will just arrive in your Amazon EventBridge account, and you can route that to Lambda or something. So that's one part. We've got another product called AppFlow, which does more that, but more on sort of the data manipulation side. So if you wanted to connect to Salesforce and you wanted to connect to some other API destinations, SaaS partners, that's a way to do it. Another thing EventBridge also has is API destinations. So literally something can come into EventBridge and you can send it to any API on the internet. It's got rate limiting and all that kind of thing. So that's sort of from the managed services kind of point of view. But something with Lambda we've come out recently is called Lambda Extensions. And this is very much a partner level thing because you've got observability, security tools, you think of your Datadogs and your Sumo Logics and your Dynatraces. These people are also doing a great job of monitoring your Lambda functions and bringing more visibility into what's happening with Lambda, even than our own tools. And so Lambda Extensions is a way for these services to plug directly into Lambda, and they can pull information about lifecycle invocations and just be able to give you more about Lambda. And that's literally built, with the express purpose of giving our awesome partners, much more information for Lambda than they had before.
Very cool. Yeah, and that was kind of what I was curious about was the sort of evolution of where these partner technologies, these third-party APIs that come in, and that was exactly kind of what I was looking for. Perfect. Julian, I want to thank you. I know you and I could probably talk about this for hours, and
yep.
We got to be conscious of time. But thank you so much for this. It's always good to get an update on what's going on, especially as we're sort of mid-year. A lot of times people wait for reInvent to get updates, but awesome to talk to you. Awesome to finally kind of get you on the show. And if anyone kind of wants to, I know you guys are always running events and running engagements. What's either a good way to go learn some more stuff, engage with you? Like, what are good ways for people to kind of engage and learn more about serverless?
Yeah, certainly. I mean, the bigger picture thing is just serverless is becoming ubiquitous in a way that each kind of thing, everyone's trying to evolve it to make it a serverless thing. So even if you can't necessarily think of a use case at the moment, or it's a bit foggy and doesn't make sense, serverless is going to be a big part of the future. Event-driven computing is going to be a big part of all of our futures. Yeah. So it's worth spending your time. Just some, you can contact me directly on Twitter. I'm Julian_Wood. We've got also a great aggregation site just for AWS serverless. AWS is a whole bunch of web pages and Twitch and YouTube and that kind of thing. But there's a website called serverlessland.com. That's serverlessland.com. And then we aggregate, and we've got learning paths which help you do some curated learning, some workshops, some fun workshops which you can learn about serverless. Blog posts are up there, videos, and all that kind of thing. And so that's a good starting point. I could give you some other blog posts to go to. That's probably the more simpler one to go and have a look. We've got an event coming up called Serverless Live, which is a bunch of people including Werner and Adrian Cockcroft talking about serverless. So that may be worth listening into. I think that's coming up in May or early June. That's something to do it. And yeah, I mean, the big thing is, AWS is building on serverless. Andy Jassy in reInvent said, 50% of all new services being built on AWS use Lambda. So, we think it's cool enough to use for our own services. And, we're not being strong-armed or twisted into using it. So yeah, I'm happy to help with any questions, on serverless in general, or on Lambda, or any of the gnarly questions you may have. I'd love to be able to help and help you build your applications even better.
Yeah, very, very cool. We will we'll get those in the show notes for those of you that are out and about, so you don't have to write things down. And Julian, thank you so much again for the time today. I had Adrian Cockcroft on mine because you just mentioned him. Thank you so much for the time today. Folks, as always, we're going to wrap up there. As always, thanks for telling a friend. Thanks for helping us grow the show. Thanks for helping us grow the community. And on behalf of Aaron and I, we will talk to you next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.